Now let's see example 3 here. So find the V0 or I0, whichever presents in the circuit, by conducting nodal and mesh analysis in both circuit A and B. So obviously, again, for each one of them, we're going to apply one method at a time. So let's see circuit A first. If we apply nodal analysis on circuit A, we obviously choose the middle node up here as the only node tried KCL. Abandon corner node, these two, and the bottom ground node. So for this node, we need to assume a node voltage as V. No need for subscript to differentiate from anyone else. And the corresponding KCL at this node is to this current, if we assume the current is towards right, and then we need the voltage at this node minus V divided by 1 kilo ohm. Obviously, 12 volts voltage source, again, is not helpful. So we have to utilize this resistance here to write the Ohm's law. So the voltage here is from this node with respect to the ground, which is nothing but exactly cross 12 volts voltage source. Therefore, the voltage here is 12 volts. So 12 minus V divided by 1 kilo ohm is the current here, towards right. It's at another current entering this node V, which is provided by the independent current source, 2 milliampere, equals to the current leaving node V, which is current through 1 kilo ohm here, towards right. So 2 currents entering the node equals 1 current leaving it. Then what is the current through this 1 kilo ohm towards right? Obviously, we're gonna use V minus the voltage here divided by 1 kilo ohm. However, what is the voltage at this node? Similar to here, the voltage here is provided by this dependent voltage source. Of course, you need to, first of all, correctly identify this is actually a current-dependent voltage source. Therefore, the labeled 4kIx is a voltage value across here and here with this polarity. Therefore, the voltage at this node is equal to negative 4kIx. So you're using V minus negative 4kIx divided by 1 kilo ohm equals to the current here towards right. So this is the KVL you need for this node. However, we are seeing 2 unknowns in this one single equation. So we have to figure out another extra equation to solve the unknowns. So what can we have? Ix is labeled in the circuit already, which is the current here. And we have discussed very clearly previously that Ix is equals to 12 volts here minus V here divided by 1 kilo ohm. So now we are seeing 2 equations and 2 unknowns. We are able to find both individually. And once again, never forget, we are looking for V0 or I0. And only I0 presents in this circuit. Therefore, it is equals to V minus negative 4k Ix divided by 1k, as we discussed. Ending up with a negative 3 milliampere. That means the true current through this branch is upward, counterclockwise, or say. This is the solution for applying nodal. If we apply the mesh analysis on the same circuit, we obviously notice there are 2 meshes, here and here, clockwise rotation direction. And since Ix and I0 are labeled here as this, we can feel free to use them as the mesh current, I0 as the mesh 2 current. So to Ix mesh here, the KVL equations is like this. First of all, we rotate and come across the negative polarity of the 12 volts, followed by positive, so negative 12. Plus Ix times 1k. And then plus the voltage across the independent current source, When we write KCL, we really like the current source, which provides us nothing but current value. However, this is KVL. What we need is a voltage cross it. Just like in the independent voltage source, we have no idea about the current through. Here, this is independent current source. We have no idea about the voltage cross either. So inevitably, we are assuming a voltage cross it as V with this polarity. And then this is the KVL. To mesh 2, we have this voltage again. However, because of the rotation direction, this is negative V now. Plus 1K times mesh current I naught. And then plus the voltage here with this polarity. Again, this is a voltage value and the voltage source. We like it for KVL. So with this polarity negative positive like this is negative 4K Ix and equals to 0. So counting again, we are ending up with two equations. However, V, Ix, I naught, 3 unknowns. We need one more extra equation to solve them. So what equation we can have? Actually is this. So the current source 2 milliampere is obviously equals to the current difference between I naught and Ix. However, it is Ix minus I naught equals to 2 milli or I naught minus Ix equals to 2 milli. We need to follow the labeled current direction here. So according to this direction, it is I naught minus Ix because the I naught current direction is consistent with this labeled current direction. Now let's see example 3, circuit B. And we are seeing V naught here, so we definitely gonna look for this voltage, which is also the voltage right across this 1 kilo ohm. Please consider this circuit, nodal and mesh as an exercise. You can pause the video and try everything all over yourself. And it required results to be calculated, so you can reach there and then come back to the video to check the solution and try to figure out why and how, and bring up the questions in the conference, of course. Anyways, I'm gonna go ahead to present my solutions. So here you can tell I'm choosing the middle 3 nodes here, here, and here to write KCLs. And these 2 nodes, I'm utilizing the given labeled voltage. For example here, the voltage at this node is equal to the 2 V naught, which is the dependent voltage source of voltage value. And here is the labeled output voltage V naught. So by doing so, I'm reducing the number of unknowns in the equations. Because otherwise, here is V1, here is V2, here's V3, 3 unknowns. Now basically, we have 2 V naught here, V1 here, V naught here, so 2 unknowns. However, of course, if you're assuming V1, V2, V3 here is still doable, okay, it won't affect you to find the results. And based on these assumptions, let's see the equations. So at 3 nodes, we come up with 3 KCLs. And a little bit hint here, so the same issue we had before. Voltage source, no matter is independent or dependent, we have no way to know the current through it. Especially it is not series connected with another resistor we can use to write Ohm's law. So we have to assume an extra unknown. Other than that, the rest of the thing basically are following the assumed current directions here, which could be different from yours, but it should be fine, because eventually you should end up with the same answer. I didn't calculate the I2 V naught since it is not something we are eventually look for. But V naught as the final answer is -4 volt. Similarly, here's the solution for the mesh. I'm defining mesh 1, 2, and 3 in this way, rotating clockwise. And correspondingly, I have 3 mesh KVLs written in this way. Here, hopefully it is not confusing that the first equation up here is loop 2. Here, not loop 1. And to writing loop 2 KVL first, I want to emphasize one thing. So this V is the voltage across the current source, because again, we don't know the voltage across the current source. So we have to assume an extra unknown. I call it V. And you can imagine I'm giving the positive polarity up here, negative polarity here. The rest of things are regular KVL things. Hopefully you come up with the same equations and then eventually can come out with the solution. Here, another thing is, by these 3 KVLs, you are having 3 equations. However, if you count, you are seeing up to 5 unknowns. So how to deal with this? We need extra equations. Actually, 2 more equations. Same idea from nodal analysis. One is actually the difference between I2 and I3 is 2 milliampere current source value. Another is the V0 just equals to 1 kilo ohm times I3 in this circuit. So we are counting 1, 2, 3, 4, 5 equations and 5 unknowns. And eventually you're going to come up with the same answer for V0, which is supposed to be negative 4 volt. Again, try yourself and then come up with questions, and we can discuss in the office hour. At last, let's see the example 4, 2 circuits A and B. I will leave both as your exercise independently, but here I'm of course going to show the solutions. And it asking for V or I, whichever present in the circuit, by conducting either nodal or mesh analysis. So feel free to choose one of them to conduct, and also try the other one as exercise. Okay? Since the purpose of all of these examples is nothing but make you become familiar with how to apply the techniques, nodal and mesh. But in the future real applications, choose whichever one you feel comfortable with. So let's see, to circuit A, the solution is here. I'm choosing mesh here first, and defining the mesh up here 1, down here 2, and here 3. And accordingly come up with 3 KVLs in 3 meshes. And one thing I need to remind is, after these 3 KVLs, I'm seeing we have only 3 equations, however up to 5 unknowns. So obviously we can't find any one of them. That's why I have to come up with extra equations. And here are 2 equations I come up by observing the circuits. They are a little bit tricky, I have to admit. However, you need to learn how to link the KCL, KVLs you're writing with the unknowns to the variables you're really looking for. Okay, this is a technique you have to learn. Extra equations sometimes, yes, tricky to find. After these 2 equations, you have 5 equations and 5 unknowns. You're able to come up with anything you want. And the last but not least, the one we really care is I0. And by observing the circuit again, it is nothing but I2, the mesh current here. Equations only. You don't need to conduct any calculation here. And as I said, as exercise, I'm also providing the solution for nodal analysis on the same circuit. Please try this yourself as well to see if it works. Further, to circuit B of example 4, I'm providing the solution for nodal analysis only. And by assumed currents up here, I came up with all of these equations. Well, yes, up to 8 unknowns and 8 equations to find everything we need, including 4 nodal equations and 4 extra equations to provide same number of equations to that of unknowns. So let me know your questions and remember to exercise the mesh analysis on this circuit B. That will be all for this module. And once again, the nodal and the mesh analysis are the core of this course. Please bring up questions and we will discuss in the conference. Thank you. See you in the next module after the midterm exam.